Welcome to the deep dive. Today we're getting into something literally under our feet. Soil crusts. These surface layers, the skin on the soil. And, well, turns out they're pretty diverse.
That's right. And our mission for this deep dive, using our Chapter 2 material, is really to, understand these different types, what makes them tick.
Yeah, maybe give us all a new way to look at the ground, whether it's the garden, a field, or like just a path somewhere.
Exactly. It might change how you see things.
Okay, so let's dig in. The material points to three main kinds, right?
Three broad categories.
Starting with structural crusts. It sounds structural.
Yeah, it does. And that's the key. They form because of physical processes.
Yeah.
Just how the soil particles and water interact.
Right, not living things involved at this stage.
Not for these ones, no. And there are four subtypes here to unpack.
Four. Okay, let's go.
First up, slaking crusts. You find these in sodic soils.
Sodics, meaning high salt.
Yeah, high sodium, technically. Yeah. And the amazing thing is, these crusts form just from the impact of raindrops.
Just rain.
Well,
yeah.
The force of the drops hitting that specific soil type breaks down the structure, the aggregates. Boom, you get a crust. Shows you the power of rain, doesn't it?
It really does. Okay, what's next after slaking?
Then you've got infiltrating crusts. These are more common on loamy soils.
Loamy, so a mix of sand, silt, clay.
Exactly. Medium texture. And the defining feature here is separation.
Separation.
Yeah, like the finer particles wash down a tiny bit, leaving coarser stuff on top. You get this sort of layering, a clear sorting of particle sizes right at the surface.
Okay, interesting. Almost like natural filtering.
Kind of, yeah. Then number three is coalescing crusts.
Coalescing, merging together.
Think of really wet soil, almost, soupy, viscous.
Right, muddy.
Exactly. As that starts to dry out, the particles just merge. They coalesce into a crust.
Makes sense. Okay, and the last structural one.
Sieving crusts. These are typical on sandy soils.
Sand.
And the key here is two distinct layers, a real contrast. You might get a layer of fine particles washed in over the sand, for instance.
2 layers. Okay, so that's the 4 structural types. Slaking, infiltrating, coalescing, and sieving.
You got it. And that last one, sieving crusts, actually leads us kind of naturally to the second main category.
Oh, how so?
Well, the second category is erosion or depositional crusts.
Ah, okay. So movement is involved.
Precisely. These often form when, say, the top layer of a sieving crust gets eroded, blown by wind, washed by water, and then deposited somewhere else.
So it's like crust recycling.
Yeah, sort of. A crust formed from the bits of another eroded crust. It shows how connected these processes are.
Right. Okay, structural, then erosion depositional. What's the third big type? You said this is where it gets really different.
It really is. The third one is cryptogamic crusts.
Cryptogamic sounds mysterious.
Well, it refers to the organisms involved. These aren't formed by just physical stuff. These are living crusts.
Living, like actually alive.
Yes. Made up of algae, fungi, lichens, mosses, bacteria. Tiny organisms forming a community right on the soil surface.
Wow. That's incredible. A miniature ecosystem.
Totally. Sometimes they're called microphytic crusts, too. Microscopic life, basically.
Microphytic. Okay. And where do these fit in?
Well, what's fascinating is they can form right on top of any of the other crust types we just talked about.
So you could have a structural crust underneath, and then this living layer grows on it.
Exactly. Adds a whole other dimension, doesn't it?
Yeah.
Especially important in dry areas, deserts and such. They help stabilize the soil, cycle nutrients.
Amazing. Just changes how you think about bare ground. It might not be bare at all.
Not at all. It could be teeming with life.
Okay, so let's just quickly pull that together. We had the structural crusts, the 4 types driven by physics. Slaking, infiltrating, coalescing, sieving. Then erosion leading to depositional crusts.
Right.
And finally, the living layer, cryptogamic or microphytic crusts.
That's the rundown. And, you might ask, why dive this deep into dirt?
Yeah, why should you, listening, care about soil crust types?
Well, because understanding even these subtle surface differences tells you a lot. It's like reading the landscape.
How so?
The type of crust can hint at the soil type underneath, the climate, how much disturbance there's been. Is it healthy soil? Is it eroding?
Right. So looking down gives you clues about the bigger picture. Useful if you're a gardener, maybe a farmer, a hiker.
Or just curious. It gives you a new lens. So hopefully next time you're out walking, maybe you'll pause, take a look down.
Yeah. Don't just walk over it.
Think about where you are. Is it sandy, clayey, wet, dry, What kind of crust might be there? What story is that little patch of ground telling you?
A good thought to leave people with. What's really going on right beneath your feet?